Welcome viewers, in this video we will see the details about cut set schedule tree branch voltages. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. One of the topic in network topology, cut set schedule tree branch voltage. To find the branch voltages and current in a network, there is set another method is available. There are two methods, tie set schedule, cut set schedule. This is coming under cut set schedule. We can treat the tree branch voltages as independent variable. Then all the voltages can be expressed in terms of the tree branch voltages. So we are going to express the voltages in terms of the tree branch voltages. As tree branch connect all the nodes in the network, we can trace the path from one node to another node by traveling around the tree branch only. So the tree branch means it will connect all the nodes, so that we can trace the path from one node to another node by the tree branches. So it is possible to express the potential difference between any two nodes. It is commonly known as node pair voltage. So we can possible to express all the potential difference between the two nodes. Now we'll consider the network. We'll see the diagram. So this is the oriented graph. Oriented graph means the graph means the network is replaced by the line. Here this line indicates the network elements. Network elements are replaced by the line. It's called a graph. If the direction also available means it's a oriented graph. We are able to see what is the direction, how it is traveling, right? So the network element replaced by the line is graph. The direction also available means it is a oriented graph. So here there are four nodes are available, A, B, C, D. Node means connection of junction point of more than one elements. Here this element 1, 8, 4 are connected. Similarly here 1, 5, 2 are connected. So the node is the junction point, connection of more than one element. There are 8 branches available. Branch is nothing but connection between the nodes. The element connected between the node is called a branch. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 branches are available. So we already know that we are going to deal the topic cut set schedule using the tree. So from this oriented graph we can draw the tree. There are n number of trees available from the oriented graph. This is one of the tree we consider. The tree is the subgraph, contain the less number of branches. Here only 4 branches we consider. That is 5, 6, 7, 8. These inner branches we consider. These outline branches are not drawn. 1, 2, 3, 4 are not available. So this tree is the subgraph, contain less number of branches. Here branch 5, 6, 7, 8 is available. 1, 2, 3, 4 is not covered. This is one of the tree. Like that we can draw many trees. So here A, B, C, D, 4 nodes, branches 5, 6, 7, 8. The potential across this branch B, node B and reference is a E1, E2, E3, E4, because we are going to find the tree branch voltage. So our aim is to find E1, E2, E3, E4. So that is more. E1 is nothing but the branch voltage between node B and reference node. E2 is between C and reference node. E3 is D and reference node. E4 is A and reference node. Here some of the branches are not covered, so that will come under the cut set. Here this branch is not connected. So here we have one cut set here and another cut set will be here. So here also not connected. So there are possible 4 cut sets are possible here. So tree is the connection of branches, less number of branches. The branches were not connected, not covered. That will act as a cut set schedule. Here 1, 2, 3, 4 branches are not connected. Outlines are not connected. So that 4 corners will act as a cut set schedule. So that is the important concept. We'll see the cut set schedule later, right? So this is the oriented graph. From that, n number of trees are there. We consider this tree. By analyzing the tree, we are able to see that there are 4 cut set schedules are available. Now we'll see what are the diagram for the cut set schedule. Assume that V1 to V8 are the voltages at the branches 1 to up to 8 respectively. So V1, V2, V3 up to V8 is the branch voltage. There are 8 branches available. Branches 5, 6, 7, 8 form the tree. We already know that the inner branches 5, 6, 7 form the tree. So V5, V6, V7, V8 are the voltages of these branches respectively. Right? This tree contains the branches 5, 6, 7, 8. The corresponding voltage V5, V6, V7, V8. Now we'll go for the further details. The tree branch voltages form a set of independent variables. To distinguish them from a dependent variable, we designate the independent variables are E1, E2, E3 and E4. Right? So the V1, V2 up to V8 is the branch voltage. The tree branch voltages indicated by E1. E1, E2, E3, E4. E1 is equal to V5, E2 equal to V6, E3 equal to V7, E4 equal to V8. So we can identify the tree branch voltage. The other branch voltage is also known as a link voltage. I already told inside the branches are available 5, 6, 7, 8. Voltage is V5, V6, V7, V8. The corresponding tree branch voltage E1, E2, E3, E4. But V1, V2, V3 is not covered. That is the other branch link. That coming under link voltage. These are expressed in terms of tree branch voltage. So V1 equal to E1 minus E2 because V1 is connected between E1 and E4. V2 is connected between E2 and E1. So E2 minus E1. V3 equal to E3 minus E2. V4 equal to E4 minus E3. Now we'll see how we are getting V1 equal to E1 minus E4. So refer this diagram. So this is the V1. The between node A and B is the V1. Right? So here V1, this is nothing but a potential difference between E1 and E4. So E1 minus E4. Similarly V2. V2 is connected between B and C. E1 minus E2. Then V3 connected between C and D. E2 minus E3. V4 connected between C and D. E3 minus E4. Right? So inside the voltages as clearly mentioned, outside the tree branch voltage is nothing but difference between these two voltages. So based on that, these 4 voltages are written, right? V1, V2, V3 and V4. So that will act as a link voltage. In case of a complicated network, this method is very tedious and confusing. Hence we write the schedule called a cut set schedule. If it is complicated, it becomes tedious. So we can go for a cut set schedule. I will refer the diagram. So this is the cut set schedule. So this is a cut set schedule. It's a diagram. Cut set schedule diagram. So there are inner branch 5, 6, 7, 8 is coming under the tree. Outside not covered. Now it is outside line also drawn. That acts as a cut set. C1, C2, C3, C4. There are 4 cut sets are available. From the oriented graph, tree is drawn. In the tree, the branches not covered act as a cut set. Branch 1, 2, 3, 4 are not covered in the tree. So branch 1 act as a 1 cut set, C1. Branch 2 act as a 1 cut set, C2. Branch 3 act as a 1 cut set, C3. Branch 4 act as a 1 cut set, C4. Right? Wherever the branch not covered in the tree, that will act as a cut set. Here 4 branches are not covered, so 4 cut sets are available. Now we'll see the tabular column. Tree branch voltage. Tree branch voltage means E1, E2, E3, E4. Already know that E1, E2, E3, E4. Tree branch voltage. The branch voltage is V1, V2, V3 up to V8. That is the voltage between the nodes. So the branch voltage. Tree branch voltage means is a E1, E2. We already have the 2 different notation. Now we can rate these 2, tree branch voltage and the branch number. First we will consider the node 1, 3 branch voltage V1. So that is connected between A and B, right? A and B, right? A and B is connected. Now consider this E1, 3 branch voltage E1. So at this point we'll analyze all the things. Here 1, 5, 2, these three branches are connected. Other branches not connected. 3, 4, 6, 7, 8 not connected. Only 1, 2, 5 connected. See the direction of the branch and the cut set. Both are opposite, right? Branch 1 and C1 both are opposite, mean plus 1. In 2, branch 2 both are same direction, mean minus 1. 3, 4 not connected. 5 is connected. 5 also opposite direction. Branch voltage and cut set schedule direction both are opposite, so plus 1, right? If the both the directions are opposite to each other, both are opposite mean plus 1. Both are same. Here also going upward, this also going upward means minus 1. The branches not connected are 0. Then we'll go to the E2. The branch voltage, 3 branch voltage E2. So E2 is available here, right? E2. Here 2, 3, 6 are connected. 2, 3, 6. Other branches are 0. 1, 4, 5, 7, 8 are 0. First we will see the 2. See the direction both are opposite. So plus 1. Then C3. Both are same direction. So minus 1. 6. Both are opposite. So plus 1. Then we will go to the C3. C3, what are the branches connected? 4, 7 and 3. Other branches are 0. First we will see the 3. 3 both are opposite direction, plus 1. 4 same direction, minus 1. 7 also opposite direction, both are opposite, plus 1. Then we'll go to the C4, the voltage E4. Here what are the branches connected? 1, 4, 8. Right? 1, 4, 8 are connected, other are 0. First we will see the 1. See both are same direction, going this side. So minus 1. 4 both are opposite direction, plus 1. 8 also opposite direction, plus 1. So accordingly this tie set schedule is calculated. See the voltage V1, V2, V3, V4, V8. Right? So the V1, we consider V1, it is connected between the node B and A. That is E1 and E4. So E1 plus 1, E4 minus 1. That also, like that also we can see that. So I will explain again one. E1 cut set schedule C1. 1, 2, 5 are connected. 1, 2, 5 are connected. 3, 4, 6, 7, 8 not connected. So 1 is connected. Both are opposite direction, plus 1. 2 is going same direction, minus 1. 5 is opposite direction, plus 1. Like that we can go for the tie set schedule. Now we'll go for the further analysis. So from the tabular column, how we can go for the further analysis. E1, E2, E3 are the cut sets. The direction which are given shown. Number of cut set equal to number of node minus 1. Refer the graph with cut set. The 3 branch voltage numbers 1, 2, 3, 4 are entered in the first column. They corresponding to the 4 branches 5, 6, 7, 8 respectively. What we did is the description is given. To fill up the first row, consider the cut set schedule C1. It cut the branches 1, 2 and 5. So the first row all entries will be 0 excepted the branch 1 to 5. Right? 1 to 5 only we are filled, other things are 0. This 1 to 5 based on the direction. Opposite direction means plus, same direction means minus 1. Similarly, we can go for the other rows. The orientation of cut set is opposite to the direction of branch means 1, 1 and 5. So the orientation of cut set schedule is opposite direction of the branch 1 and 5. Hence its value is plus 1 and minus 1 in the first row. Below the branch 1 and 5. The direction of cut set C1 is same as that of 2. So it enters as minus 1 in the below branch 2. Right? The same direction means minus 1, opposite direction means plus 1. Similarly, using cut set C2, the second row is filled up. Cut set C3 and C4 also filled up the third and fourth row respectively. By using the same rule we can fill. So after writing this, what we can do? After writing the schedule, we can get the equation of 4 branch voltages in terms of the tree branch voltages. Thus, column 1 gives the equation for V1 in terms of tree branch voltage. In the similar manner, V2 to V8 also obtained in terms of tree branch voltages. By seeing the column of the cut set, we can get V1 equal to E1 minus E4. Right? How will get V1 equal to E1 minus E4? So this is the cut set schedule available. Vertically what we have? Tree branch voltage. Horizontally we have branch voltage. See the V1 here, plus 1 minus 1. E1 is plus, E4 is minus. So E1 minus E4. E2, E3 is 0. So based on that we can write V2. E1 is minus 1, E2 is plus 1. So E2 minus E1. V3. E3 is plus 1, E2 is minus 1. So E3 minus E2. Like that we can write.